Welcome to addressing modes of 8086. First of all, what is addressing mode? Why we studying the addressing mode? So addressing mode helps us to understand the types of operands and the way they are accessed while executing an instructions. Uh, let's coming this video. We are studying the different types of addressing modes in 8086 with an examples. Here, the 8086 have 8 different addressing modes. We are studying one by one. The first, we are studying the immediate addressing mode. Here, in immediate addressing mode, in this type of mode, the immediate data is a part of instructions. So, the data is initialized within the instructions. For example, uh, move AX comma 10 ABH. Here, the AX is a 16-bit register and the 10 AB is a data, 16-bit data. Before that executions, the AX register is empty. After this instruction is executed, the 10 AB data is moved to the AX register. The AB is moved to the AL register and 10 is moved to the AH register. So this is a normal. So data is directly initialized within the instructions. That is the immediate data. The next coming to the direct addressing mode. In this type of addressing mode, the 16-bit memory address is directly specified in the instruction. I have one example. So move AX comma within the bracket 5000H. This the 5000 is a address of the memory. The address of this memory have some data. That data is moved to the AX register. Before these instructions, the AX register is empty. The memory of 5000 have a 22 and 5001 have a 33. So 8-bit data. This data is moved to the AX register after this instruction is executed. So this is a direct addressing mode. And next coming to the register addressing mode. In this type of addressing mode, the data is stored in the register and it can be a 8-bit or a 16-bit registers. Okay, so the source and destination both are specified in register, means it is a register addressing mode. Here for example, move AL comma BL. So it is a 8-bit register. So source is a BL register, AL is a destination register. So both are a registers. So it is a 8-bit registers. Another example is a move AX comma BX. So it is a 16-bit registers. So source and destination both are 16-bit registers. So before this executions, so BX registers have a 10AB and AX registers have a FF33. So after this instruction is executed, the BX register data, the content is moved to the AX register. That means AB is moved to the AL register and 10 is moved to the AH register. This is a register addressing mode. And next coming to the register indirect addressing mode. Here come from this name indirect. So here the memory is specified indirectly. So the address of the memory locations which contains the data or operand is determined in the indirect way. So one example, I have one example, move AX comma within the square bracket BX. That means BX register have a some address. BX register have a some address. That address have a some data. That data is moved to the AX register. Before that, AX register is empty. The memory containing the BX registers, the BX register in address is 5000. Here, in this memory, the 5000 have a data 22 and 5001 have a 33. This data is moved to the AX register after this instruction is executed. So the memory address is indirectly specified in the instructions. So one example, so just to answer these questions, so move 7000h comma cx, which addressing does instruction above belong and why? Here, so this is a direct addressing mode, because 7000h within this bracket the address is directly specified. Here the CX register have a data is a 4356. This data is moved to the 7000H memory locations. Okay. So 7000 memory locations, so CX register data is moved. So next, coming to the indexed addressing mode. In this addressing mode, offset of the operand is stored in one of the index register. And DS, that is the DS is a default segment of index register SI and DA. Here one example, move AX comma within the square bracket SI. Before that, the AX register is empty. The SI index registers have a address is a 5000. That 5000 and 5001 have a some data. That data is moved to the AX register after this instruction is executed. So simply the index register have a some data. Index register have a address. That address have a some data. That data is moved to the AX register. The content of SI registers is moved to the AX register. That is the indexed addressing mode. So here the index register is specified. Next, coming to the register relative addressing mode. In this mode, the data is available at the effective address formed by adding an 8-bit or a 16-bit displacement with the content of any one of the registers BX, BP, SA and DA in default register segment. So already we know BX is a base register, BP is a base point register, and SA source index and destination index. So this address is moved to the add with a displacement address, displacement value. For example, move AX, 50H within the square bracket BX. Within the square bracket means, so within the square bracket any of the data, any of number or register means that is specified the address of that register or data. Okay, so in the 50H is add with the base register address. So before that AX register is empty. So BX register have the address is a 5000. That 5000 is add with the 50. So the final index address is a 5050H. So 5050H in the memory is memory contain the data is moved to the AX register. So the 5001 and the 5002 data is moved to the AX register after this instruction is executed. So this is a register relative addressing mode. And next, coming to the base plus index addressing mode. In this mode, the effective address is formed by adding content of base register to the content of index register. Okay, so base plus index, so base register plus index register address is combined with any give the any one of the address. That address containing some data, that data is moved to the AX register simply. So for example, move AX within the square bracket, that means BX register and SI register within the square bracket, that means segment register, index register have a some address, BX register have a some address. So BX register have a address is a 10,000 and SI have a 20, BX register have a 1000 address and SI register have a 2000 address. This two register addresses added means 3000. This 3000 final index address is have a some data. That data is moved to the AX register. So this is a base plus index addressing mode. So base address and index address are plus added, then after given some address, that address have some data, that content of data, and that data is moved to the AX register. And next, the last addressing mode is a base relative plus index addressing mode. It means base relative means it have some displacement, 16-bit or 8-bit displacement address it have. Is add with a base register plus index register. For example, move AX, 50H BX register and SI register have some address. Here the BX have a 1000 address and SI have a 2000 address. So both are add with 3000. The 3000 is add with the displacement value is 50H. So 3050H is a final index address. This address have a some data. That content is moved to the AX register. So 3050 have a 12, 3051 have a 34. It is moved to the AX register, AL and AH register. So these are the base relative plus index addressing mode. So thank you.